All right, it's time for hyperbolas. Vertices, foci, and center of this guy right here. First off, it's a hyperbola because of the minus sign and it equals 1. In this case, we have the y stuff happening before the x stuff happening. So this is how we label things in this matter. First off, this is a hyperbola that opens uppy downy. Not to be confused with Robert Downey Jr., famous actor. What we're going to do is we're going to compare this to y minus h squared over a squared minus x minus k squared over b squared equals 1. Using this information, we can say that if negative h is positive 8, then positive h is negative 8. And if negative k is positive 2, then positive k is negative 2. And if a squared is 36, then a is 6. And if b squared is 25, then b is 5. All right. We are going to need c. The nice thing about this is, unlike ellipses, if we want to find c, it's actually Pythagorean theorem. A squared plus b squared equals c squared. So what was that? That's 36. Plus 25 is c squared. Those guys add up to 61 equals c squared, square root it. And you really don't get anything special except for the fact that c is going to equal the square root of 61. Nothing happens there. All right. Let's go in not the order that we're given. Let's do the center part first, just because the center is hk. And in this case, the center is going to be negative 8 and negative 2. Okay. The vertices are given to us as h, k plus or minus a. Okay. So h is negative 8. K is negative 2. So we'll do negative 2 plus 6 is 4. Negative 8. And then negative 2 minus 6 is, again, negative 8. Okay, so those are our vertices. Our foci, focus plural, is h, k plus or minus c. So there's our negative 8 again. Okay, k is negative 2, so we'll do negative 2 plus root 61. Then the other option is going to be negative 8, negative 2 minus the square root of 61. And yeah, there you have it. Hyperbolas, they're a lot. They're a pain.